Hello! In this video, we'll explore the key concepts of AWX, which is an open-source web-based automation platform built around the Ansible project. We've already set up an AWX instance with public networking, so we can access it directly and dive straight into the demonstration. If you'd like to follow along and do not already have an AWX instance set up, please check out our other videos where we show you how to launch AWX quickly. AWX comes with many features, but only a handful of these components are essential for getting productive on day one. The main components we need to understand are projects, inventories, and job templates. Let's start with projects. AWX automatically creates a default project for us, and this project is backed by Git, which is considered a best practice. The idea is that you store your Ansible playbooks in a Git repository, for example on GitHub, but then you can hit the sync button and AWX will pull those playbooks directly into the system. This approach gives you a full infrastructure as code experience that is declarative, which aligns with core Ansible philosophy. Next, we have inventories. Think of inventories as groups of servers or other devices that you want to target with your automation. In our demonstration setup, we have a basic demo inventory that contains just localhost, so we can run jobs without needing any additional setup. The third key component is job templates. AWX provides a default template that runs a playbook called helloworld.yml. This template essentially acts as a reusable launch button for your playbooks. When you hit launch, AWX creates what's called a job, which is an instance of that template running against the hosts in your inventory. Let's go ahead and launch this default job to see how it works. Since the Hello World playbook is very small and simple, this job will run quickly. If you go back to the Jobs tab in the top navigation, you'll see both system management tasks and your own job runs listed there. Now let's move beyond the default setup and create some additional assets of our own. We'll add a new project called Web Server Demo. For this demonstration, we'll set the source control type to manual, though in real-world usage, you would typically wire this to Git for full infrastructure as code capabilities. When we select manual as the source control type, AWX asks us to specify a local path for the playbook directory. However, this directory does not exist yet, so we need to create it. We can do this by executing into the pod and creating the directory structure we need. Let's create a directory called web in the var lib AWX projects path. We're running as root here, and most of AWX is also running as root in this container, so the permissions should be fine. After we create the directory and refresh the interface, we can see that the directory appears as an option. Remember that in a real production environment, you would connect this to Git for full infrastructure as code functionality, but the manual approach works perfectly for our demonstration purposes. We'll keep this project in the default organization, which is simply a logical grouping mechanism within AWX that helps you organize your assets. You can have multiple organizations if needed. Now let's look at inventories and hosts. If we go to inventories and then look at hosts specifically, we can see that we currently have only localhost, which is perfect for running quick tests without additional setup. However, if you were targeting real servers instead of localhost, you would need to set up credentials. Credentials in AWX handle authentication information like usernames, SSH keys, and API tokens. You can create different credential types for different purposes. The network credential type is specifically designed for uploading SSH keys to set up your inventory connections. Now we need to create a playbook to use with our new project. In the web folder that we just created, we'll add a new playbook file. Let's create a file called provision.yml and paste in some basic playbook contents. This will serve as a placeholder for now, but remember that these are standard Ansible playbooks, so you have access to the entire Ansible ecosystem to help you write these playbooks in a declarative way. Next, let's create a job template to use this new playbook. We'll create a template within our web server demo project, and we'll continue using the demo inventory. Notice that the system has already detected our provision.yml playbook automatically. When creating job templates, you can choose between two different types. One type actually runs the playbook and executes the tasks, while the other type performs a dry run safety check to validate everything without making any actual changes. This check mode is useful for testing and validation purposes. You can also add credentials to your templates, as well as labels, which serve as searchable metadata that you can use to organize and filter your jobs later. Think of a job template as a blueprint for automation. Each time you run the template, you can prompt the user for different inputs like labels or credentials, rather than having these values hard-coded into the template itself. This flexibility makes templates much more reusable. Everything else in our template configuration looks good, so let's save it and then launch our first job. Unlike the demo template we used earlier, this template now asks us for labels because we enabled the prompt for labels when we configured the template. However, we immediately encounter an error. The system reports that it cannot find the directory we specified. This is puzzling because we know the directory exists and the permissions appear to be correct. Let's double-check the permissions to make sure there are no issues there. The directory definitely exists and has appropriate permissions. There are no special user restrictions that would prevent access. At this point, we should note that AWX provides an option to relaunch jobs if needed, and each job attempt gets its own version number for tracking purposes. Issue we're experiencing is likely related to how AWX handles job execution. The jobs actually run in separate task pods, and these task pods need access to the same directory structure that contains our playbooks. So we need to create the same directory structure in the task pods as well. Let's examine our task pods, which are where the actual job execution takes place. We need to create the same web directory in the task pod environment so that it can access our playbook files. After creating a directory in the task pod, let's try running our job again. This time, the check run passes successfully. Since our validation check worked, let's check the template from check mode to an actual run job type, save the changes, and launch it again. Excellent. With the actual run configuration, we get our success message and see the full execution of our provisioning playbook. The job completes successfully, and we can see all the tasks that were executed. Now, while the manual directory creation was a clever workaround to get things working, this approach reveals a fundamental issue with our setup. The real problem is that we do not have proper persistence configured for our AWX deployment. Currently, there is no persistent volume claim that works properly for both the AWX task pods and the web system. To solve this properly, we need to upgrade our AWX deployment to include persistent storage. We can do this by modifying the AWX specification to set project's persistence to true. We also need to specify a storage class, such as zonal read-write many, which can be backed by a file store service that provides managed NFS capabilities. Because AWX uses a custom resource definition for its setup, provisioning this read-write many storage volume can take a minute or two to complete. The advantage of this approach is that once the persistent volume is created, it will be mounted to both the web pod and the task pod automatically. This eliminates the need for manual copying of playbooks between pods. You can monitor the persistent volume claim status, and when it shows as bound, both pods will reinitialize automatically and start using the shared storage. The task pod will show as pending while this process completes, but once everything is set up, you'll have automatic and seamless access to your manual project files without needing to copy playbooks across different pods. That covers the essential concepts you need to understand to get started with AWX. We've explored projects, which organize your Ansible assets, inventories, which define your target hosts, credentials, which handle authentication, job templates, which serve as blueprints for automation, and jobs, which are the actual execution instances of your templates. With this foundation, you can begin experimenting with AWX and building your own automation workflows. If you'd like to support the channel, consider starting a free trial of our new software design tool, which is linked in the description, and let us know what you think. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.